Hi, we're an engineering team from Thayer School of Engineering at Dartmouth, and we've been working with the Dartmouth football head coach Eugene Tevens on building a mobile tackling target. Football is the most watched sport in America, however its full contact nature presents dangers to players. The rising incidence of concussion and recent awareness of the dangers of these injuries has led to changes in the way that games are officiated and players practice. The tackle has been broken down into three components: the pursuit, in which the ball carrier is chased down, the breakdown, in which the tackler stops in front of the ball carrier, and the finish, in which the ball carrier is wrapped up and taken to ground. The tackle is now practiced in each of the three steps individually, and by limiting contact exposure, players don't spend sufficient time practicing safe tackling form. Football teams are therefore in need of a dynamic system which simulates player motion as realistically as possible in order to safely practice tackling form in a game-relevant scenario. There are several products on the market which attempt to solve this problem. This first is the stationary dummy, which is in use by most teams and allows a static target for players to tackle. The hanging pad attempts to mobilize this, however only does so in one direction and doesn't allow players to integrate the three phases of the tackle by bringing the pad to ground. Drag dummies have come the closest, however their unrealistic weight distribution and ineffective acceleration causes unrealistic tackling environment. With this in mind, and based on conversations with players and coaches, we've come up with a set of driving requirements including unpredictable motion, safety to tackle, it has to function in the same conditions that a football team practices in, and it needs to give realistic tackling resistance. In addition, we've come up with a set of performance requirements which will allow our device to be highly effective, including easiness to reset, which allows a large number of repetitions in a short period of time, which is essential for large football teams. It needs to be easy to store and take on and off the field, and within the budget of a football program. With this in mind, we took a step back and looked at the real problem. We need a safe way of effectively practicing tackling. And so, the solutions we came up with grouped into three categories. We could make tackling safer, use existing technology, or innovate to mimic player movement. In order to make tackling safer, we first looked at using tackle suits. These are a layer of padding which players can wear to help protect them against injury. These don't mitigate the risks effectively of player-to-player contact and don't protect against concussive injuries. We looked at hit shields, which essentially accomplish the same thing, however with reduced player mobility. We then looked at using existing technology, such as making more effective drills, or practicing at thud pace, which is essentially the first two steps of the tackle, however after the wrap-up, the player is not brought to ground. We also looked at employing animals, however we decided that this wasn't ethical, so we moved forward. This led us to the conclusion that we needed to develop some sort of mobile tackling device. It would need some sort of infrastructure, whether it's freestanding on a track or hanging. It'll have a certain number of degrees of freedom that are given by a type of motion, whether that's leaning, rolling, sliding, or launched by wheels, tracks, a sled, or rope. It needs to be reset by some means so that it can be tackled by the next player. And this motive force is going to have to come from somewhere. With this in mind, we came up with design alternatives which combined different elements that we had brainstormed. We vetted these against each other and decided that freestanding dummy would be most effective to eliminate risks of injury from infrastructure and also allow with ease of setup and takedown. This die-wheel dummy uses parallel wheels and a freestanding geometry which allows the dummy to be self-righting after tackled. The simple design has a skid ring which allows stability and can move in any direction on the field. This accomplished almost everything we were looking for, however, it didn't quite have the instant acceleration in any direction we were hoping to have. When we vetted the designs against each other, we determined that an RC ball drive would accomplish these. The specifications we were using were based on baseline scores from NFL combines and were weighted against each other using a pairwise comparison. The fact that this remote control ball drive met all of our specifications and was the clear winner meant that we would move forward with it. Our initial concept design had an upper padded cone for a tackling target with a lower area that contained the ball drive system, which allowed for omnidirectional motion and immediate acceleration in all directions. And so we started looking for ways to control this ball. First we found the Sphero, which is a children's toy, which is powered inside by essentially a Segway, and has the omnidirectional motion we were looking for. We thought, okay, great. How can we scale this up and use it for our purposes? And we ran into a number of issues with this internal drive system. We thought, well, we'll keep it simple. Let's look at external drive systems. And we found these ball balancing robots, which use Omni wheels and a solid-state gyroscope to keep them stable. And, while this would be effective, it was overly complex. We want something that's going to be simple and robust enough to be tackled over and over, and still cheap enough to be afforded by most football teams. And so we kept looking around, and we found the traditional ball mouse. The ball mouse uses a ball to drive rotors in multiple directions, and we thought, well, we can just take this concept and put it in reverse and use rotors to drive a ball. That's essentially what we did. So we came up with this model of a ball which is powered by these Omni wheels. Their perpendicular nature would give motion in both the X and Y directions, and a third Omni wheel will allow rotation to justify the front of the tackle dummy with the way that the user is facing. And so this concept design has a number of key components, including the padding, the motors, control systems, ball and chassis, and the drivetrain. We immediately dove in with prototype development using whatever materials we could get our hands on. We finally came up with a proof of concept model which used a Sphero as the ball drive and styrofoam, foam core, and paper as the dummy. When this worked exactly as we had suspected, we moved forward with a full-scale prototype of the drive system, as we saw this as the greatest risk to our success. We wanted it to be as modular as possible, and so we used 2x4s and aluminum. This would allow easy adjustment to lock down key design parameters, such as ball height, ball size, and position within the base. We continued using a set of motors in U-brackets. These were on hinges, which also allowed for easy adjustment of the ball. We started out using a set of remote control tank motors. These were desirable because they came with a remote control system and a dual speed controller, which would allow us to independently control each motor. While these proved highly effective at controlling the ball, they lacked sufficient torque to actually make the system drive. And so we upgraded. We had a 1/40th horsepower motor lying around. But our back-of-the-envelope calculations showed that for our 150-pound final prototype, we would need 4 horsepower motors. Operating with a motor with 1/100th of that power and a prototype at 1/10 of the weight, we were not surprised when this motor too lacked sufficient stall torque. And so we kept looking around for a good alternative to buying expensive motors at this stage. We just wanted design validation. And we noticed that the cordless drill that we had been using this entire time met all of our specifications. We came up with a rig to attach it to our Omni wheels and were able to test our device. And so fully assembled, our initial prototype of the drive system, while it wasn't pretty, provided some great design insight. Using the remote control tank motors, we were able to achieve a high degree of control. However, this revealed a number of other issues. Not only was motor power a large issue, but the eccentricity of the ball became apparent. Using springs and some other tensioning systems, we were able to overcome this challenge. Using the cordless drill, this testing also revealed a number of challenges that we'll face in the future. Beyond motor power and the irregularities of ball shape, we'll have to work with asymmetrical drag from the Omni wheels. In the future, we'll need to use opposing Omni wheels. The turf blades and infill, as suspected, became a large issue. we'll use brushes in order to keep them out of key components. Our final product will consist of an upper padded foam section made of a lower density open cell foam, which is given structure by an inflatable tube. This prevents any risk of injury and has a great strength to weight ratio. The lower portion will be made of a higher density closed cell foam, which will protect the ball cage and all control system components. The control system we've selected is remote control, using a dual speed controller to control each motor individually. We have batteries selected, and a joystick will offer intuitive control by any operator. The CAD model we built of our final product allowed us to perform a motion analysis to ensure that it will still be self-righting. With the force applied to imitate a tackle, we found that it was. With a production cost of almost $2,000 and a projected sale price of around $5,000, which is on par with other products on the market, we found that a startup company which will use loans to finance all costs will be profitable by the end of the first year, and this is with 20% growth per month in mind. The fact that there are over 40 professional teams and 200 NCAA teams in the market for a product like this means that by the end of the second year, we will be well into the profitable region, and we believe that there is a serious market feasibility here. We have an aggressive project timeline and hope to have a working prototype done by mid-February. This will allow testing and revision to take place and for us to have a deliverable by March. Thank you. Please feel free to contact us with any questions.